what we have studied in unit 1, that we are going to summarize in this lecture. Okay, so in this unit, very basic concepts we have studied for the engineering mechanics, that if some force is there such like this, then we can split this force into two components. One is parallel to x-axis and second one is perpendicular to x-axis, that is in y direction. Okay, so this is the very basic thing. If certain angle given, if some angle is given theta, then you can have force F cos of theta, and here the next component F sin of theta. This is the basic thing that we have studied. This is your force F. Okay, F cos theta, F sin theta. Theta is the angle made by force with x-axis. This is your x-axis, and this one is y-axis. What is the meaning of this? That this force is been splitted into two components, and if you take the resultant of these two forces, now this component is also an individual force. Remember this thing. This force F cos of theta and F sin of theta has some value, right? If your force F is having some value given, suppose that if this value is 10 Newton and if this angle has some value, if this angle is of 30 degree, okay, then 10 cos 30 and 10 sin 30 will be the value of these two forces, 10 cos 30 and 10 sin 30, right? So therefore these two individual forces are also components, and these components also has some value. These components also has some magnitude, that is 10 cos 30 and 10 sin 30. So 10 cos 30 and 10 sin 30 has some value, right? So therefore, if you take the resultant of these two forces, that is 10 sin 30 and 10 cos 30, that resultant will be again come to F is equal to 10 Newton. Okay, so therefore this F cos 30 and F sin 30 are the two components of 10 Newton, and for these two forces the combined resultant is F is equal to 10 Newton. Okay, so same thing is there. And what is the formula to find the resultant? You all know the formula, R square is equal to Fy square. This formula we are continuously using, right? R square is equal to Fx square plus Fy square. So you put these two things in this formula and you will get the answer, this Fy square, and you can put this to Fx square and you can get this answer, R is equal to 10 Newton. Okay, so this is the same thing that we have studied. Okay, after that we have again studied one more important thing, and that is the moment. Okay, how to calculate the moment? See here, today we are summarizing the unit 1. Today we are summarizing the unit 1. So keep it attention here. If certain force is there, okay, and if you split these forces in two components, again, if you split this force in two components, F cos theta, F sin theta, F cos theta and F sin theta. This is your force F and this is your angle theta. Okay. Now you have splitted this in F cos theta, F sin theta. Then you can find its moment about certain point. You can find its moment about certain point. Okay. So that moment also we have studied. Okay. Now if some object is there, suppose that some object is there. Okay. If suppose that some object is there, such object, such lamina is there. Okay. And here you ask to find the value of moment acting on this object. Value of moment acting on this object at this point. At this point, and you have been given certain distances. You have been given certain distances. You ask to find the value. Okay. Now suppose that your this distance and this distance are given. These two distances are given. Let us suppose that this distance is your 3 meter and this distance is 5 meter. Okay. Now I am clearing your concept. Okay. Now in this numerical, if they ask you to find moment at point A, asked you to find the moment at point A, and suppose that this is your point A. This is your point A, and you have been asked to find the moment at this point A. So therefore, how you can find this moment? First of all, you have to split this force into components. You have to split this force in two components, and you can find the moment by its components. Moment by its component means, what is the definition of moment? Moment is nothing but force into distance. What is the moment? Moment is nothing but force into distance. Moment is equal to force into distance, right? But what is the Varignon's theorem that we have studied? That the summation of moment of the components is equal to the moment made by the resultant. Okay. Now here what is the resultant? Here your force F is resultant and F cos theta and F sin theta are its component. Two components. We have splitted this force. When the force is inclined, then only we split that force. Force is inclined, then only we split that force. Okay. So therefore, for this particular force, we have splitted this force into components, F cos theta and F sin theta, right? And you have been asked to find the what will be the moment at the particular point. So therefore, you have to calculate the distance of that particular component with the point. So therefore, now what is the distance of F cos theta with the point A? 3 meter. Here you can see 3 meter is the distance of F cos theta with the point A. Okay. So therefore, now this force is going in anti-clockwise direction. This going in here anti-clockwise direction about the point A. So for anti-clockwise, your direction will be positive. In the calculation, you take it positive. Okay. So therefore, plus what you are calculating? You are calculating the moment. At which point? You are calculating moment at point A. Okay, so therefore, first moment will be positive f cos of theta, f cos of theta multiplied by positive f cos of theta multiplied by 3 meter. 3 meter is the perpendicular distance. Now remember, the distance must be perpendicular. So this angle is 90 degree. This angle, right? This angle is 90 degrees. So therefore the distance is perpendicular distance. The distance is perpendicular distance. Okay. So therefore f cos of theta multiplied by 3 meter will be the moment by the f cos theta at point A. Moment by the f cos of theta at point A means action will be at point A. I have also given you the example of door, right? You apply the force at your door, but the action is taken at the point hinge. So therefore, this is your door and this is point A is your hinge. So therefore, you are applying this f cos theta force here, but the action is taken at point A. So therefore, action of moment we are calculating at point A. So therefore, this force f cos theta multiplied by this distance perpendicular, f cos theta multiplied by 3. Okay, and now the next force is f sin theta. So f sin theta is going in which direction? F sin theta going in clockwise direction. In clockwise direction. So therefore, its sign is negative. Its sign is negative minus f sin of theta multiplied by minus f sin theta multiplied by, now what will be its distance? Its distance is given as, you have to find the perpendicular distance from point A. Now from point A, the distance is 5 meter. Here the 5 meter distance is given. You can see this 5 meter distance from f cos sin theta, f sin theta to point A. The distance is 5 meter. This distance is given. You can see this distance as 5 meter. This distance is 5 meter. Okay. So therefore, this f sin theta multiplied by 5. This will be your what? Moment. This will be your moment by the next one. Okay, by the next force, that is f sin of theta. Okay, so now you have got the moment at point A. Now if your values are given, if f is equal to 10 Newton and your theta is equal to 30 degree, if these values are given, then you can find the answer. You can find the answer. If f is equal to 10 Newton, this thing is given, and if theta is given as 30 degree, then you are able to get these two forces, f cos theta and f sin theta. Put these values in this equation and you can get the moment by the force F at point A. Moment by the force F at point A. You are able to get it. Okay. So this is nothing but the summary for your moment. This is nothing but the summary for your moment. Okay. Now, after getting this moment, we have also seen the equilibrium. We have also seen the equilibrium. What is the equilibrium? In equilibrium, you are having the three conditions, that is summation of fx is equal to 0, summation of fy is equal to 0, and moment at any point is equal to 0. If these three conditions are satisfied, then only we can say that your body is in equilibrium. So this thing we have also seen in previous lecture and numerical. We have also seen the support reaction numerical. So in support reaction numerical, we have seen that how you calculate the support reactions for the beam. Suppose that this beam is there and the support reactions you have to calculate. This one is your first end point, this one is second end point, and you are asked to calculate the support reaction at the point A and at the point B. Okay, this they have asked you. This one is your RA, that is the reaction at the point A, and this one is the reaction at point B. Now, how you will calculate this? How you will calculate this? Simply, I will tell you that if suppose that your 50 Newton force is applied here, if 50 Newton force is applied there, and if the distance between these 2 points is given as 10 meter, if this distance is 10 meter, then also the distance is given from point B is 5 meter. Then from point A also the distance will be 5 meter, and here you are able to get the support reactions as this force will be equally divided into the 2 parts. This 50 Newton force here will be divided into the 2 equal parts. So therefore here your RA, that is reaction at point A, will be 25 Newton, and reaction at point B will also be 25 Newton. So this is nothing but the support reaction. This is nothing but the support reaction. These two will be the support reaction, RA and RB. So do you remember this thing? That here it will be equally divided. But if it is not equally divided, if some other forces are given, then also you are able to find out the, what we can say, support reaction, to find the support reaction, right? So how you able to find that support reactions? By using the equilibrium condition. You assume that your beam is in equilibrium condition. If some additional forces are given, suppose that one more force is given here, its value is 20 Newton, and the distance is suppose that 2.5 meter. Okay, now how you will calculate the support reaction? Now the equal classification or equal splitting of this 50 Newton will not be there, right? So now two forces are there. One is the 50 Newton, second one is the 20 Newton. Okay, so therefore now you can use these conditions, that is summation of fx is equal to 0, summation of fy is equal to 0, and moment at any point is equal to 0. These three conditions we can use here. Now there is no force in x direction, as the all forces are in vertical direction. 50 Newton is vertically downward, 20 Newton is vertically downward, RA is vertically upward, and RB is vertically upward. So all forces are in vertical direction. Okay, so therefore your only summation of fy is equal to 0 we can use, and therefore how will be the equation? First one will be the minus 50 Newton, because 50 is going in downward direction. We have also seen the sign convention. Okay, we have also seen the sign convention here, that is positive x-axis and positive y-axis. This one is your positive and this one is positive. Okay, this sign convention also we have seen, which is also important. Okay, and this one is negative. For moment, what is the sign convention? For moment, we have used the clockwise as positive and anti-clockwise as negative and anti-clockwise as positive. This sign convention we have used for the moment. This sign convention we have used for the moment. Okay, so therefore by following the sign convention here, you can get first one -50 plus 20 minus 20, because all two are in negative direction, plus RA, that is support reaction at point A, plus RB, support reaction at point B, because they are in upward direction, is equal to 0. Now this is what? This is your summation of Fy is equal to 0. Summation of Fy is equal to 0. This is the second condition that we are using here. Okay, and next one is now what we are able to use? Summation of moment at point A is equal to 0. This we can use. And summation of moment at any point. So therefore, we can also consider summation of moment at B is equal to 0. We can use these two conditions. Summation of moment at point A is equal to 0. Summation of moment at B is equal to 0. Therefore, first one, summation of moment at A is equal to 0. Okay. Now, for A is equal to 0, your moment of RA will be 0 because it is passing through the same point. So the distance of RA from point A is 0. So therefore, this moment will be your 0 in case of RA. Next force is 50 Newton. 50 Newton is going in clockwise direction. So it will have negative sign. So it will have negative sign. Okay. So therefore, this minus 50 multiplied by 5 meter, minus 50 multiplied by 5 meter will be the moment of first one. Okay, next one is minus 20 multiplied by 7.5. Minus 20 multiplied by 7.5, because 7.5 is so here minus 20 multiplied by 7.5. Now your next force is RB. RB is in anti-clockwise direction about point A. RB is going upwards, so it is making an anti-clockwise movement. You can see here, anti-clockwise. Its direction is anti-clockwise about point A. So therefore, it will have a positive sign. So plus RB multiplied by its distance is 10 meter from point A multiplied by 10 meter. Okay, so now the equation is complete and is equal to 0. That is summation of moment at point A is equal to 0. Now from this equation, you are able to find the value of RB. If you solve this equation, you also put this numerical in your assignment, you will get the value of RB is equal to how much? Right? You are able to get the value of RB is equal to how much? Right? And after that, you are able to get the value of RA. So in this way, you will get the value of RB as well as RA. Right? Put the value of RB in first equation, that is this equation, right? This one is your equation number 1. So you can put this value in equation number 1 and you will get the value of RA. Okay, so you also solve this numerical in your assignment. This will be your last numerical for the assignment. You put the value of RB in equation number 1 and you will get the value of RA. Okay. So in this manner, you will get the both values. So now our time has ended and our lecture will end here. Okay. So do practice more for the unit number 1. Moment is the most important thing in this unit. Remember, moment, calculating the moment is most important thing in the mechanics. So practice for the moment.